Hello, champions. Welcome to our Form 2 mathematics lesson. And today we continue with our topic, area part of a circle. This is our lesson number 2, and we shall look at the area of a segment. I'm your teacher, Mr. Wanyoike from Mary Hill Girls High School. Welcome. In our previous lesson, we looked at the parts of a circle, and today we continue exploring the parts of a circle, and then we can get area of various parts of a circle. In our diagram A, where we have a circle, we have the parts. The arc, the one in red, is a small section or part of a complete circular path of a circle. Then we have a sector, the one shown outlined in green. Then we have a segment, the one outlined in blue. In diagram B, we have two types of segments. And they are divided by a chord AB. The line AB is called a chord. So we have the major segment, the one in white, and the minor segment, the small one, the one in green. In part C, we can combine the segment plus a triangle, and then that will give us a sector. In other words, if we draw a chord from A to B, I'm not talking about C, in diagram C, we draw a chord AB, then the sector that we had, the one was shaded in a green, then we'll have a triangle and a segment. In part D, it is that segment that we can find its area using the area of a triangle and the area of a sector. Now that you know what a segment is, in this diagram, the segment we are talking about is the one shaded in blue. And we have the sector, as we did in our previous lesson, we have the sector ACKB. That sector enclosed by that path, ACKB, is a sector, and this sector is made up of two parts. Is made up of a segment, the one in blue, and a triangle, the one in yellow. The triangle is ACB. Now, to get the area of the segment CKB, then we follow the following steps. Step number 1, you get the area of a sector, and the sector here is ACKB. Remember, we said the area of a sector is given by theta over 360 pi r squared, where pi r squared is the area of a circle, and theta over 360, that theta is the angle at A in this case. Once we get the area of the sector, then number 2, we need to get the area of the triangle. The area of the triangle, you can use any of the formulas that you know. You can use the Hero's formula. You can use a half AB sine theta, or you can use a half base times height, depending on the measurement you're given or the measurements that you are able or to calculate. Then number 3, to get the area of the segment, then we'll say it is the area of sector you found in step 1 minus the area of the triangle you found in step number 2. And that will give you the area of a segment. Let us now look at an example. And in this example, the question is, find the area of the segment AYB shown in the figure below. If the radius of the circle is 21 centimeters and angle AOB is equal to 120 degrees, you are told to use pi as 22/7. Now, in order to work out this question, we'll follow the steps we outlined in the last slide, and we'll say area of the segment AYB, the one shaded in blue, is equal to area of the sector, which is OAYB, minus the area of triangle OAB. Area of the segment AYB will be given by area of the sector OAYB minus the area of the triangle OAB. Now, the area of the sector OAYB will be given by theta over 360 times pi r squared. And our theta here is 120. Then we have been told to use 22 over 7. Then the radius is 21. So the area of this sector will be 120 times 22 over 7 times 21 times 21. That gives you, when you simplify 22 times 21, which is 462 centimeters squared. So the area of the sector OAYB is 462 centimeters squared. Then we now get the area of the triangle OAB. The area of triangle OAB can be found using the formula a half AB sine theta. This triangle will use a half times 21 times 21 sine 120. And when you evaluate that, you get your answer as 190.96 centimeters squared. So now the area of the segment is 462, which was the area of sector, minus the area of triangle, which is 190.96. And you get the area of the segment, the one shaded in blue, as 271.04 centimeters squared. Now, students, we have come to the end of our lesson today. I hope you have learned how to get the area of a segment, where you get the area of the sector first, then you subtract the area of the involved triangle, and that way you can be able to get the area of a segment. Now below is some work involving that work we have done today. Ensure that you do your work and you post your work on time on our Google Classroom platform, and ensure that the images you send are very clear. If you can be able to do it on PDF, the better. And below that, after the assignment, we have the answers for the previous lessons. Mark your work, and where you have questions, ask, and make sure you do corrections. Have a blessed day.
Feel the love he felt for us when he bore our sins. Listen to his words, let them come alive. If we know him as he is,